Everyone. This is Tech Laughs and Bites, and today we have a special guest in the house. He's a data scientist and also an artificial intelligence and machine learning pioneer. His name is Simone. But before I tell you all about him, well, I think he should introduce himself to us. So Simone, could you tell us a bit about yourself and how you got into AI and machine learning?
Sure. Nice to meet to everyone. Thank you, Castle, for the invitation. As you said, I'm a data scientist. I came from Italy, south of Italy, and now at the moment I live in France. And I'm a data science is almost 10 years that I'm in the field.
Mm.
Why I got into this field, and especially why I chose the natural language processing. At first, I was a physicist,
Okay.
but once I started to heard about a machine, and especially something that really got me, that was the Turing test.
Okay.
I don't know if you know about it. It's basically how you can recognize if you are talking to a machine or to a human being, and this really got me. But it was like said, "Oh my God, I want to do that. I want to study more about that." And
Okay.
so I started my path in data science and NLP.
Oh wow, no. Okay. And so you have been doing this for the last 10 years. You have been doing machine learning for the last 10 years, right?
Yeah, data science, machine learning. Yeah.
So you started way before the AI buzz era now. So like you went way before. You started early. So I think that's definitely a plus for you.
Yes, I think we can say I started before ChatGPT, so it was the big change I think in the domain, and also to show people, also people that are not technical people, what AI machine learning can do. So yes.
Awesome. And in the early days of machine learning, when you started, what have you seen differently from what we have now?
Different is that you didn't have LLMs, so you have to do everything by hand. It was more based on mathematical approach, statistical approach.
Yeah.
And there, I think also companies were not so ready to use their data.
Yeah.
They have data, not like today, but they were not ready to use them.
Hmm.
They didn't want to invest in that.
Yeah.
But today things are changing. I think also because with the AI, the LLM, all everything that is happened today
Hmm.
really changed, because people, companies understood that they can leverage their companies, their businesses, using data science and machine learning. So this is, I think, the biggest difference in uh, in the field.
And what do you great. And what do you think that as many companies or businesses think about machine learning and they're like, wait, this actually has value. Like back in the days, they didn't really think it could do so much right now that we are doing with, machine learnings, and we're able to build so many great applications with that. And what do you think really changed? Like, what was the wake up call the industry had?
Yeah. Great question. It's a great question. Well, actually, I think there are two factors to consider. The first one is the amount of data.
Okay.
Before, I think not so
Okay.
many companies so many data, and then I think
Okay.
companies started to have more data because we had new technologies like just social media. Unfortunately, the COVID that forced people, to buy online, to do a lot of activities online. And the second one, I think, yeah, is the AI. Especially, there is one uh, event in the timeline that is the creation of this paper that is attention is all you need. This was a paper that changed really the way
Okay.
we did natural language processing. That was then what we
Yeah.
allowed to create LLM as we know today, that are ChatGPT, the first one, but
Okay.
also all the other
Okay.
one. And I think this was really a game changer
Yeah.
because now today everybody, even small companies with 1 2 people, can use AI and can
Hmm.
leverage the data they have. This is like
Yeah.
wow, it's amazing. I totally understand hype around it. Even if I like
Absolutely.
classical methods to do data science and machine learning, but
Yeah.
I totally understand. It's like tomorrow, to make a comparison,
Hmm.
it's like tomorrow someone can compete, uh, can do a marathon, even if he hasn't trained for for the past time of his life. So I think it's incredible.
So pretty much what you think that changed is the data. So with all of these applications that we have, with all the technology application, but social application, you think that data was able to be generated to actually really see the value in machine learning and AI, of course.
Yeah, I think it's a match of both things, data. So people started to collect more data, and at some point,
Mhm.
with this paper and the LLM, the progression, these
Yes,
all this technology, they said, okay, now we have a lot of data and we can use them
yeah,
easily. We can
yeah,
customize. We can do a lot of cool stuff. And I think it was the
yeah,
match of these two aspects.
absolutely. That is awesome. And speaking about data, so we know that at the moment there is something computer vision does. So computer vision can detect cars, can detect bicycles, trucks, even pedestrians on the road. But obviously, what would you do you think that computer vision will be able to detect things like um, mileage users in a car? So you know how you put the box, all
Hmm.
of the box, and it
Yeah,
detects every single thing on the road. So do you think that computer vision in the future would go way beyond that and start detecting things like people's mileage usage, people's fuel consumption, and all of that stuff? Do you think that AI would get to that computer vision would get to that stage?
for sure. I think, yeah, for sure. I think there will be more and more application. This is
Yeah.
something that we can. I saw in the last years.
Hmm.
Every year there are so many new models.
Hmm.
Each week, basically, it's impossible to stay update with all the things that go out, all the new technologies. So
Hmm.
for sure, I think there will be new application also in computer vision, as you say.
Yes.
I think also China is long far away in that. They are ahead. They are using lot of technologies,
Hmm.
and for sure there will be new new models, new application every day.
Mhm.
And
Yeah.
yeah,
Yeah, I mean, it would be great to see things like, how many number of passengers are in a car. It'd be great to see things like fuel consumption. I just think that, the future of technology, especially when it comes to computer vision, in the future, we would really, really see a lot of use cases. But like you mentioned, China is already doing so much with computer vision in
yes,
in in, in this lesson. So yeah, okay, that's great. So I mean, my next question is, when you use an LLM, um, it could give you a different response. So, for example, you ask an LLM and you say, "Oh, I want you to give me the latest G wagon," right? And you train it on a set particular G wagon specifications, and you ask it to give you one of the G wagon's type that you trained the data on. But sometimes you find out that when you then prompt it to give you a specific car, it doesn't, and sometimes you try again to prompt it and it does. So it's more like sometimes the prompting nails it and sometimes it hallucinates. So my question there is, what do you think is the reason for this?
It's a great question again. For sure, it happens. It can have different responses, and this is the base of the fundamentals of LLM, because they are also statistical models, very complex
Yeah.
statistical models, very huge. You have a lot of parameters inside an LLM, but they are
Mm-hmm.
still statistical machine. So they don't are deterministics. They have a math function. They have what we call weights. They do their computation, and they can give different responses based on different inputs. So even if you write the same input, there are some
Mm-hmm.
parameters that are set in an LLM that are called, for example,
Mm-hmm.
the temperature. That tell you
Mm-hmm.
the temperature tell you how random is the response. So more low is this value, and more you have deterministics responses. More higher is this value, and more you can have randomness. So even if I give the same prompt, I don't know, you are interested in car, maybe, and if you give the same prompt, if the temperature is 0, it will be
Mm-hmm.
more deterministic. So it will give you always the same response. If
Okay.
you start to higher this value, using a higher value
Yeah.
of temperature, is going to give you responses that are more randomness. It's like entropy. I don't know if you a bit used to the definition, but when entropy start to increase, particles in
Yeah.
physics can go in different way, in different path, and this is the same thing
Mm-hmm.
here. Each time an LLM give you a response, is computing the
Mm-hmm.
probabilities of the next word.
Mm-hmm.
So these probabilities can change. So maybe if we are talking about cars, the probability that he will talk uh, about car domains is higher.
Mm-hmm.
One more, this temperature is higher, and more you can pick different words. More the
Okay.
temperature is low, and more is stick on the more known words. So
Okay.
it's a bit how it works. Is a statistical model anyway,
Okay.
but it uses all the fundamentals of natural language processing. Uh,
Mm.
they say in the 50 that you can know the meaning of words by the
Okay.
company it keeps. Like people, you can say that someone is an athlete because he go out with people that do a lot of fitness. The same
Okay.
is for words. So
Okay.
if you don't know words, but you know
Mm-hmm.
the surroundings,
Yeah.
so we are talking about Volkswagen, Ferrari, just because I'm
Yeah.
Italian. So you can you can guess that
Yeah.
the word that I'm talking about is a car brand,
Yes.
and this how LLM are trained. So
Yeah.
they are trained in a way to predict the next word based on
Mm-hmm.
the context. So if a
Okay.
context is about car, the, the probability that his response contain words about car is higher. But
Okay.
he has been trained the LLM on billion words. So
Mm-hmm.
the fact that he knows a lot of text about that give
Mm-hmm.
us the idea that he's thinking and that is really generating something that he knows, but
Yeah.
actually he can generate that because he saw so many texts that he can
Okay.
associate that word and the prompt that you put in uh,
Okay.
to something similar that he has already seen.
Okay.
I don't know if it
Also,
was clear, but
yeah, I mean, it's just one thing that I also wanted to ask also as well. So you did make mention of, putting the prompt, and is that um is that part of sequential as well? So, like when you give it like you train an LLM on different cars, right? Different brands of cars, just like you mentioned.
Mhm.
And then you said something about it thinking about the next word to use. So because you had put in a G Wagon, for example, in the first time, you know, and you then put in something like I love Lamborghinis. And then you put in something like a Lamborghini, for example, in as a prompt the next time. So already the LLM has already saved in his memory that you are just talking all about cars, right?
Mhm.
Okay.
Uh,
And that would still be part of sequential as well. Is that right?
yes, just to say, I love Lamborghini too. It's amazing. Really amazing. Also, the story about the founder is something crazy. It's really very, very amazing to see, but we will talk about it next time. And yes, to to come back to your question, for sure,
Okay.
you have like what is called a context window.
Okay.
So when you talk with LLM,
Yeah.
he has like a past history
Mm-hmm.
on what you have asked, what
Mm-hmm.
he replied, and what you asked again. So you
Yeah.
can have like what is called the context windows. And
Okay.
the amazing thing is that it can remember things that you
Mm-hmm.
said before. So, if you write in ChatGPT, you can have a conversation with
Mm-hmm.
him, and he remembers that you asked something before. And this is something that is changing today because in the first years, in the first stages or LLM and ChatGPT,
Yeah.
this context windows was very small. So
Okay.
it can remember, but it could not remember everything, and it was not so precise. And
Okay.
today, one of the things that is changing, and
Yeah.
especially Gemini with
Okay.
Google is doing really, really well, is to
Mm-hmm.
increase this context window in
Mm-hmm.
order to remember a lot from the past. And so yeah, it has to be trained on the data that he knows, but it also can reuse something that we said before.
Okay. Awesome. So basically, what you are saying is that the data that is being used to train the LLM has to be, it has to be a lot of data, and of course, with all of the parameters, the temperature, the weights, and all of that needs to be accurate to actually stop an LLM from hallucinating.
Yes, this is a this is a sensitive question because yeah, as you said correctly, uh, you can train, you can give the good context, you can try to set this parameter in order to have a good response, but um, they are statistical models, so they can hallucinate, so they can give responses that are not correct. Today, the grammar is always correct, so in the first stage, they could really answer something different, but today is more smoother. So basically, you can have an answer, and you think
Mhm,
is correct because it's quite convincing that it could be correct. But as you
mhm.
say, um, they can hallucinate, and this is because they are statistical models. So they don't really think in the way humans think, and so they can give information that are not real, that are not the good answer we are expecting from them. Yeah, and this is for two reasons. The first reason is that it has not context enough
Okay.
to answer our question, and second one is
Mhm.
that they try to be condescending with us. So I don't know if you ever tried to do a question. He replied
Mhm.
something, then you say, but I thought that it was like I wrote before, and the LLM
Mhm.
tends to be condescendent with you and say, oh, maybe you are right because I'm wrong. Because and this is one of the problem. But we cannot do so much. But for the first one, for the data and the context, there is something that is called retrieval augmented generation. That was something that
Okay.
was used a lot these years, and this is used a lot
Okay.
by companies. That is to
Okay.
put inside the LLM once you have a
Okay.
prompt. For example,
Okay.
let's come back to the cars that we love. You can put a data set with
Okay.
specific information about cars. So if you are talking about Lamborghini, the LLM can use this technique that is called retrieval augmented generation that can, once you tap a prompt, it can
Yeah.
retrieve information about cars and
Okay.
put your prompt, this
Okay.
information that you retrieved, in the
Okay.
LLM, and so it can give
Okay.
answer that are more correct than the one that it would give without this technique.
Great. That's really great to know. Thanks for sharing, Simone. So still on the topic of machine learning. So,
Sure.
I mean, you know how, I mean, you've been in this machine learning industry for way longer. So you know how you could perform a machine learning task. For example, you take an algorithm like regression, and you could use regression for like a different number of tasks, like a variety of tasks. There is just this one task that sometimes you would use regression for, and even after you've done all of the evaluations, you find that your regression model was sort of like really really didn't give you the right inference. So let's take, for instance, I use regression model for maybe water potability, to kind of like know, to find out which of the factors is affecting the cleanness of a water, right?
Hmm.
Water that is safe to drink, for example. And I might then want to use the same regression model, because obviously we know what regression model does, and we want to use it to predict maybe the car prices again. I don't know why I'm always picking cars.
It's
Okay.
okay.
But yeah, so we wanted to predict car prices, for example. But you find out that you got way more inference, accurate inference, when the regression model was applied to the water potability project compared to the car prices predictions.
Mhm.
What do you think might have been the reason for that? Knowing fully well that this algorithm, could do both tasks. And of course, you might have used the regression for a number of tasks in the past. So what do you think might have just been the reason for this?
It's a great question. I don't know the dataset, so maybe we are going to guess what could
Okay.
happen.
Yeah, yeah, just hypothetical.
Just hypothetical. Well, there is one thing that is called linearity and the
Okay.
relation between features, between
Mhm,
the input that we are giving to the model compared to
mhm,
the target. So if these features are really dependent with the target, so
mhm,
as you say, the purity of the water or the car, the price of the cars,
mhm.
uh, this could be easily problem resolved with, for example, linear regression or
Okay.
other simple model, classical model,
Okay.
just because there are some clear pattern of, I don't know, I'm not an expert in in purity of the water, but maybe there are some
Yeah.
really clear indicators that
Hmm.
tell you, for example, the colors. If the color,
Hmm.
it's not crystalline, maybe you can say, okay, maybe I don't want to drink this water, and
Yeah.
maybe it's easier to spot this pattern. And even a model that is really simple, like linear regression, as you said,
Okay.
can do the job and can do it great job. But
Yeah.
there are some other domains, some other problems in which you don't have this real clear pattern.
Yeah.
So you can say that the relation between the input features and your target is not linear. So
Okay.
you need something more powerful than just a line, and you need models that are more complex to get the job, that can really try to deepen inside the data and find the, the good function that can give you the price of the car. But I'm
Absolutely.
just to say, I'm really a totally fan of a simple model when they can work. So so
Yeah.
for sure, uh, guys don't just use LLM to do everything, just
Learning, how it was used, why we are just saying the value of machine learning, and your answer was actually a great response, and why businesses had not seen the value all of this while, and I think your answer about we didn't have so much data as much as we have now. I think that was actually a really, really great answer, because if you think about it, um there was so much value in actually using all of these algorithms. I mean, we have so many of them out there that are being really, really that actually bring out so much value in a business. And but just to come back to what you said about the scenario where regression might be used for one use case, and the other use case, regression would not give you an accurate result, even if you um, compute all of the evaluations. I
mhm.
think that you mentioning about same thing back to the data set again, because obviously, as we know, everything is strongly dependent on data. So the more data we have, and of course, the factors that also affects the that also the factors in the data sets, would also determine what machine learning algorithm will be used. So I think that was really, really, that was really a great response. So yeah.
Thank
Yeah.
you.
Okay. So so recently we had GTC, Jason's NVIDIA's GTC conference, and during Jason's conference, he had a really nice display of robotics, which I thought was really cute.
I saw it, and I totally
Oh,
agree with you.
I thought that was really, really cute. I mean, and the really cool conversation he had with Blue, it was almost like, is he actually having that conversation with a robot? I mean, that as imagine everyone getting a Blue in their houses, they probably won't be bored anymore.
I would love, honestly, to have one of it in my house for sure.
Honestly, but again, with watching that, obviously we know that robotics are being trained on reinforcement learning, and of course it's always the trial and error attempt to get it to do the things that has been assigned for it to do. So I mean, after seeing what Nvidia, Disney, and the other company put together, you know, what do you think that in the future, how do you think reinforcement learning will evolve? we evolved to handle something as serious as a medical surgery. So when I mean a medical surgery, I mean like a heart transplant. Like, do you
Mhm.
think people are going to trust it? For example, you are, in a situation whereby you've got maybe a friend, someone and of course, as a technology advocate, and they come to you and they say to you that, well, we think we are going to be using a robot on someone that what will be your
Mhm.
first response to that?
Your question are becoming more harder, harder than we go. We discussed that. Just joking, just joking. Yeah, yeah. Of course, it's. I thought about it. Of course, that was I think one of the first thing that I started thinking when I started this path, and
Okay.
I think things are changing because it's really like a perception. I remember that I had something this discussion some years ago, and I remember
Okay.
that people are not so prone, to get to use AI, artificial intelligence, robot in their life. It
Hmm.
was like a sci-fi, comedies. What they would love to have it, but they were not so used,
Hmm.
to have AI in their life. But today, I think that people are changing because now almost everybody use AI, and I think that people are getting more used to have AI in their life. So I think it's
Okay.
just you know uh, the habit to have this kind of new technologies, these beings, these AI beings
Yeah.
in our today life. And yeah, if you ask to me, I just we look at the probabilities, but just because I'm a data scientist, so yeah, if the
Yeah.
human error is 1% and the robot's error is 100 times less, I'm
Mhm.
gonna choose the robot for sure.
So basically, you're saying that before you can approve a robot to perform a medical surgery, it would have gone through a rigorous trial and error period. Like it would have, you would have seen it do the whole, like from the whole simulation, and you would have seen it pass the different probably like tests that it needs to pass, and this, before you can trust it to say, okay, yes, do a go ahead to actually perform a surgery on someone,
Yeah, this is, I think, for sure. For sure, it would be a wide range of experimentation.
Yeah.
Very, very rigorous A/B testing, probabilities, and once we have that, yeah, for sure, why not? I think.
Yeah.
I think I'm not in the sector, I'm not in the domain, but I think that advancement in health
Hmm.
with AI is one of the most impactful things that AI can do.
Yeah.
And for sure, I would like to see more research on that, more investment on that, because it's really something that can impact human life, and you can see
Yeah.
it. So if you can save life, you can improve the quality of life. But just give all robotic doctor, and I'm fine. I'm fine with it for sure.
I mean, obviously, though, we're not trying to say that it's going to replace doctors, because I don't believe that robotics can actually replace doctors, because doctors are always
For
going to
sure.
be needed. But of course, with things like aiding, enhancing, and of course, trying to be like an assistance to serve more people, I think that's what the real value is.
Yeah, yeah, for sure. But I think that medics are never enough, is for the population. So yeah, we won't replace human medics, but if we can have robotic colleagues, it would be great for me.
I know. Oh, I actually didn't think about that. Robotic colleagues. So when you come into the office in the morning, you would have programmed in what to say to you, would you?
Yes.
Okay, okay. Well, that's really, really great, though. But yeah. So now we're talking about robotics, and of course, you know, with all of this technology, we know that we utilize things like CPUs, GPUs, and TPUs.
Mhm.
So if CPUs are the dependable workhorses, GPUs are the gym guys for lifting heavy graphics, and TPUs are the AI nerds for solving equations at light speed. Could you give me an example of where you would use each of those processing units and what tasks you would do with them?
Well, because for me, I would always use a GPU to do everything, but
I
I'm
know,
joking.
I know, totally agree.
I'm joking. I'm joking. Now, CPU, I think they are indispensable because they have a low cost, so you can really do amazing stuff. You don't need having a GPU or TPU to do normal stuff, I will say. Even today, an LLM, you can run your LLM without a GPU. The graphical units are needed to train
Mhm,
an LLM, but you can still use your LLM um,
mhm,
locally, so on your computer, using
mhm.
a CPU. So there is this program this called Olama that
Okay.
allow you is a library that allows you to split the LLM on the
Mhm,
CPU of your computer, so you can use it without a GPU because GPU are expensive. There are not
mhm.
many,
About
and yeah, and also for the environment, they are not the best choice because you need a lot of more electricity compared to CPU to perform the same
yeah,
operation. So as for the models, I always advise to when you can use something simple, just use the thing simple. Then the CPU is not as fast as the GPU, so we will not have your answer
fortunately.
in in some seconds, but you will have your answer in 1 minute. But if you can wait, it's okay. You can do it. Uh,
Yeah.
or the rest, yeah, we leave a TPU for research with,
Mhm,
for researcher, and
mhm.
GPU when you need to do some with graphics, with generative AI, with images, or you need high speed and you need uh, high fast performances.
Yeah.
But in case your PC works fine, your old computer laptop can work fine too.
Yeah. Also, I mean, yes, you know, I totally agree with you. TPUs are way advanced, and you know, research work and would you use TPU to create train more data on, maybe if you wanted to create an LLM, or you use a GPU?
I use a GPU, so
Use a GPU?
yeah, I'm more CUDA guy,
Yeah, I think
NVIDIA guy. Uh, but yeah, it depends more on the architecture that you have. They were developed by TP were developed by Google, so if you are if you use that particular architecture, totally go on. But GPU
okay.
are more mainstream, so they are used. There is more documentation. They are more valuable, and I think there are much more mechanism to parallelize.
Yeah,
It can be done even if you don't have so many resources. It's the case in all the DeepSeek and these new models that are doing the same thing with much more less power than we did before.
yeah. Also, that is just great. It's just great. So now that brings me to, you know, we're talking about LLMs, we're talking about CPUs, GPUs, and TPUs. Now let's talk about quantum computing. You know, so it's, well, I think it's still in the early stage of development. I mean, we're seeing what Microsoft is doing with quantum computing. I mean, they just released Majorana, which I think is already out there in the markets. So my question for quantum computing is, do you think training AI models will be so fast that by the time you click run, the model is already predicting the test data? Or will it be just so advanced that it finishes training the data in a couple of seconds?
Very difficult question. I'm not an expert of the domain of quantum
Okay.
computing, but I think that for now we are a bit far from that, in the sense that today there are some uh, computers, some quantum computers, but they cannot really perform complex, algorithm. They're not doing complex calculus. So I
Okay.
think we are a bit far from that. But
Mhm.
in case they achieve that, it will be like game changer. I think that we need to rethink everything we do today. Of course, I
Yeah.
think the architecture, the LLM will not be the same. Maybe we will be able to change the model,
Mhm.
um, because today the way they works is based on
Mhm.
the amount of data and on the
Okay.
amount on the size of the model. So
Yeah.
the LLM is able to give us a response that is quite good because he has
Mhm.
seen so many data, as we said
Yeah.
before. So if you have seen all Wikipedia
Yeah.
and all the books and all the internet, there is a chance that
I know,
it's not
right?
so big. They
The
are
entire Google
huge.
search.
Yeah. Exactly. They are
Yeah.
so huge that they can basically, it's like they store everything inside the
Yeah.
parameters. So
Mhm.
they can remember what they have learned,
Mhm.
just because it's like the matrix, that he can remember everything he has learned, and it can give a response. But maybe with quantum computing, we will
Yeah.
not use the same architecture. So we will use an architecture that will be maybe more closer to what human do today. Human don't
Okay.
need to read millions of text to
Mm.
to give a response, but they
Mhm.
works in a different way. So
Yeah.
basically, in the future we will be able to reproduce that
Okay.
architecture using maybe quantum
Okay.
computing, but not sure. But I really hope I really hope it happens.
Great. I mean, so basically, what you think is that quantum computing would be used to kind of like build LLMs way much faster than it is, like how long it will be used to how long we now build LLMs. So it would be way much faster to build something like an LLM, with quantum computing.
I think that maybe it's not just a question how fast it answer, how fast it's trained, but really that it could change the architecture. So
Okay.
basically, it can really change the way we do calculus today inside the LLM, and
Okay.
really use another architecture that maybe is different and don't need it doesn't need all these parameters. So maybe it will need
Oh.
less, smaller
Mm,
size, uh,
mm,
less energy, less
mm.
resources.
So that brings me from we're talking about quantum computing and how fast it will be in the future to build LLMs. Now that moves me to transformative models. Obviously, we have ChatGPT, we have Mid Journey, we have Perplexity. I mean, all of this, transformative models. Do you think that they will become so advanced that one day they start to tell us what the future is?
A Nostradamus model, yeah, yeah. Well, it's a great question. As I said, I think that the the way they are done today, the
Yeah,
architecture that we are using today,
yeah.
uh, achieved very good results and is achieving very good results. but I don't know if just scaling up, so adding more parameters, more words can really change the way they think. Today we have these huge models, but I don't know
Yeah.
if just scaling up and adding more parameters and adding more
Yeah.
data, because we already
Yeah.
used basically all data that we have. So we have now a problem where to get the data to train LLMs.
Mhm.
And already
Mhm.
today, we don't have so many data. We don't have more data to train. So maybe
Yeah.
basically to achieve like a human being uh, state of the art, thinking and capabilities, we will need to switch the paradigm and use different architectures, not the one
Mhm.
that we have today, that we are using today, just scaling up. And
Yeah.
but for sure, yeah, they are becoming more and more effective in predicting uh,
Mhm.
events and customizations. Or
Mhm.
I'm not sure that they could
Mhm.
be Nostradamus and be like prophetic,
I
but
know,
they
right?
are quite good. They are quite good. Yeah.
So, would you be surprised if today we had you go on ChatGPT and you type in who's going to be the next president of the United States of America, and it gives you a name? Do you think you'll be surprised? I mean, do you think that that's the future? That's where the models, the transformative models, are going to? Oh,
More
we're
than
still
surprised,
way.
I will be scared because if, if an
I
LLM
would be
can.
too. I would be too, to be honest. I will definitely be scared if you could actually
Yeah,
type. Gonna be the next president, you know, of a country. But yeah, that is oh yeah, I will be.
yeah, it would be quite scary because you could do that for everything, even for your life. So you can ask what I'm going to eat tomorrow, and what will be my wife, or it would be
Mhm.
scary, quite scary. So I
It
prefer
would
to have
be.
the the illusion that I can choose my my path, that I have free will to choose,
Absolutely.
and also that
Absolutely.
as humankind, we have free will. That
Yes.
everything is not deterministic.
Absolutely. I agree with that as well. I think, at a certain point, you want to have some control over some things, not going to ask, not typing on ChatGPT and then you just find it just suggests, oh, maybe your next week meal plan, this is what I think you're gonna be eating next week. I'm like,
Yeah, exactly.
yeah, absolutely. Okay. That's really good to know. Um, so let's move on to agentic AI. So now we have agentic AIs for literally everything. I think the engineers, machine learning experts, and AI experts, and developers, and software engineers, software developers, and everyone in the tech industry is building agentic AIs. So basically, with all of these different agentic AIs that we have for different industries and different use cases, what do you think, or which industry do you think is not currently using agentic AI? Or where do you think that, well, that industry, they're really low on, using AI?
Well, before answering this question, I I want to tell you what I think about that, because
Okay.
today I think there is a bit of confusion. Some people
Okay.
call everything a bit agentic AI,
Mm-hmm.
but I think we are a bit far still to that,
Okay.
because
Okay.
you know today everything seems be an agentic AI, even simple automation. You have an automation that just call an LLM to do an action, and is called like, okay, this is an agentic AI. But maybe I think the original definition is that agentic AI can choose what you want to do. So there are no
Mm.
rules. So it's not like a
Okay.
classical automation when you say, okay, go to internet,
Mhm.
take this page, this data, and put in my
Mhm.
database.
Okay.
This sounds to me like more an automation. Just perform a
Mhm.
single task that that you have
Mhm.
rules. Say, okay, if something happen, do that.
Mhm.
Else, do something else.
Mhm.
Uh, the idea of agentic AI is that LLM can choose what they want to do. So basically, you have a memory, you have a model,
Mhm.
a module that
Mhm.
decide that is a bit brain decide what the other LLM are gonna do, the other agents are gonna do. And
Mhm.
for now, I don't know if uh, we are so advanced that we can use this architecture to do all tasks, because there are some tasks that where we need to have still humans that can judge if this is the good choice or not. I think maybe I like more the second definition, because agentic AI, especially again, gives a lot of confusion in people that maybe are not in sector and thinks, okay, I can build something that
Mhm.
can think alone and decide for me what is best, what are the choices. Yes, you can do that,
Mhm.
but maybe not for sensitive task or big task. You can do that for a task, if even if hallucinates and shows a path that you will
Mhm.
not choose, that is not correct, it's fine. But for more complicated task, I think we are still a bit far in that.
Okay.
I'm not saying that we are
Okay.
not going to do that, to use that, but I think maybe we need still some time to a perfect
Okay.
architecture that can say, okay, I'm an agentic AI.
Okay. Okay. So, what do you think, or where do you see the industry going with agentic AIs? Like, what do you think? Well, I should say, when do you think we need to what level do we need to get to build what the agentic AI that you just talked about?
I think everything depends on the model. So basically, it's why
Right?
I like to call them LLM. Just LLM. They are
Yeah.
LLM at the end. So yeah, we
They
are
are they
talking
are
them.
actually LLMs.
Yeah, yeah. But I just talk talk about them like LLMs.
Yeah.
I think
Pretty
once
much.
we reduce the hallucinations,
Yeah.
I think this can be really done easily. But when
Mm.
still you have hallucination and you can have these kind of problems,
Mhm.
uh, it will be complicated to do sensitive tasks. But yeah, for now, if you want to do a scrapping, and if you need to do simple tasks, I think
Mhm.
this is already be done. Like ChatGPT, Manus AI.
Mhm.
There are some companies that are developing that quite
Okay.
successfully, but for simple tasks.
Okay. So it's
For
it's
now.
pretty much we're still at the stage where we're just doing simple tasks with
Yeah, yeah,
e-
exactly, exactly,
okay. Okay.
exactly.
Awesome.
Maybe at the end of the year we will have something amazing, because really every 2 weeks there is a new model, a new company. So
Absolutely.
maybe it will be very fast, but for now it's still a bit embryonial.
Okay. I was asking, I said, when it comes to, agentic AIs, based on the simple tasks that you're talking about right now, um, what much more harder tasks do you envisage um agentic AI, doing? So could you think of any other use case where you think, okay, well, now I'm gonna call this an agentic AI. Now this deserves to be called an agentic AI based on the complexity of the tasks being given.
Yeah, I think the difference relies on the difficulty of the task. So that
Mm-hmm.
will not just be like search for flights on the internet, but
Okay.
something that humans do today that could be
Okay.
replaced. So basically, I think the most difficult part is decision making. So not just
Mm-hmm.
perform a task that I gave you, but decide which task I need to to do.
Mm-hmm.
So
Yeah.
it's not just uh, you have to perform. You, you have this goal, and you have to choose alone the task you need to do that to arrive
Okay.
to the goal. And I don't
Okay.
see today something that yeah, you can do it today, but for more simple tasks and things that require not so high level capabilities. But when we talk about business and decision making, uh, it is a bit more complicated. So you need still to implement some kind of rules that, like, safe rules, a guardrail. That is not really the correct word, because guardrail is used for
Mhm.
something else in LLM, but something that can assure that your LLM is doing the right choice.